Hey kiddos, we got lesson 5, construction techniques 3, perpendicular lines and angle bisectors. So our learning goal is let's use tools to solve some construction challenges. All right, wonder what tools we're going to use. All right, so in our warm-up with 5.1, two circles, point A and B are each at the centers of circles of the radius of AB. Okay, so basically they're saying we got two circles, both with the radius of AB. Okay, so here to here. All right, that represented by that line segment, right? Compare the distance EA from here to here to the distance of EB. So what do you guys think the distance is from EA to EB? What do you think the relationship is? So go ahead and pause the video, make your conjecture, and we'll follow through. Okay, so hopefully you paused it and you noticed that EA should have the same distance as EB, right? If you were to create line segments, you could probably see that. Also, if you created the two line segments, you would actually create an equilateral triangle, right? And that's from the previous lesson, I believe lesson 4. All right. Let's see, compare the distance of FA to the distance of FB. FA to FB, what do you notice? Go ahead and pause the video. What do you notice? All right, so hopefully you notice that they are also the same length. All right, so FA is equal to FB. Third question is a draw line EF and write a conjecture about the relationship with segment AB. So let's draw a line for EF. So that's from here to here. Oh, what's the relationship between EF to AB? And we've seen this before, right? And this is perpendicular bisector. All right, because why? Because the 2 points, EF, right, E and F, they are at the points of intersection for those two circles. All right, oh, and my dog goes crazy. All right, let's move on. Activity, make it right. So here's line L. Okay, so this whole line is line L. They gave us a point, point C, and now they're saying use a straight edge and a compass tools to construct a line perpendicular to L that goes through C. All right, so we should probably have the compass tool being used. Let's create another circle. Notice there's a point here, right? So I'm going to create another circle on that point. Get a radius to be the same as the first circle that I constructed, right? And then we have to construct a line that goes through C. Ooh, that's actually the tricky part, right? So what can we do? Can we create a third circle? No, that doesn't help us. What would help us? Because right now, if you notice, we can create a perpendicular bisector. But how are we going to be able to create a perpendicular bisector that goes through point C? So what if I actually see how my perpendicular line does not go through that point? What if I created a bigger circle? Let's say from here to here, all the way around to there, and then I create an even bigger circle at the edge of this circle. From, actually, let's move that. Oop, undo. How about here? There we go. Do you see it? So sometimes it's just about where you want to be able to construct your circles, your compass, to use your compass tool. Okay, that line is definitely perpendicular and it does go through point C. So just to let you know, this circle right here, okay, I don't know if you see my cursor, I didn't need to do that. Okay, that was just me fumbling around until I realized where I could place the compass circles to get my 2 points of intersection that would actually create the perpendicular line that cuts through point C. All right, let's go ahead and try activity 5.3 to bisect this. Now, they give us an angle, right? And the first step is they estimate the location of point D so that angle ABD is approximately congruent to CBD. So basically, we're going to create a point in between this angle somewhere that'll cut this angle perfectly in half. Now, how can we do that? Well, we did perpendicular bisectors with the compass. I don't see why not. So I'm going to go ahead and try to center a circle on B to the length of A. All right. I'm going to go ahead and try that. See if that gets me anywhere. And then I'm going to go ahead and construct a circle on centered on A to the distance of C, just out of curiosity. And from C to point A. Now, do you see anything? Because I don't, right? So we have our first circle. What if I did this instead? What if I went from here to here instead of going to point C, and then with here, that point of intersection to point A? Do you see that? Look at that. So it's a perpendicular bisector, right? The two circles and the whole bit. But what I first had to do was I had to create a circle centered on B, right, with a radius of A. Now, once I had that, I had 2 points of intersection, right? Point A and this point over here, we'll call it, I don't know, point F, And then basically they say um, wherever the third circle goes is where the intersection is of the first circle from centered on B. Okay. Now the 2 points of intersection from your two circles, your second and your third circle, that allows you to create the angle bisector. So it'll cut perfectly in half for that angle. So first things first, circle B, then circle A, and then after circle A, the third circle goes on the intersection of circle B and this line BC, all right, or ray, I should say, BC. Okay, and then 2 points of intersection, draw your line, and it cuts the angle perfectly in half. We'll practice that as time goes by. In fact, I recommend that you practice this on GeoGebra. Try to recreate this on GeoGebra. You can do any type of angle, and as long as you construct these circles the right way, all right, you should be able to create your line. All right, use a compass, straight edge to create a ray, and we did that, right? We did that up here. So this blue line connected by these points of intersection, that is part 2. Take turns with the partner. So go ahead and practice this, all right? Create your own angle, which you can totally do. So you can do this on GeoGebra. with yourself, create a random angle, all right? And then try to recreate the steps. So first step, create a circle. You can pick any length, all right, along any line you want. For example, I'll just pick that one right there. And then I'm going to create a second circle with the compass tool. And I'll go, let's see, from here to here. Okay, so these are the points of intersection from the first circle. And then I'll do one more circle centered on that point there. With the same radius. And do you notice how the 2 points of intersection? So I actually want you to be doing this with me, all right? I want you to be going through on GeoGebra and just recreating what you're seeing me do. Ta-da! All right, and that is an angle bisector. Now, of course, your angles will be a little different. The sizes of your circles will be a little different, but that is the exact process to create an angle bisector. All right, for each angle that you draw, explain your partner compass moves. So definitely type your steps, so like first step, right? Construct a random angle, right? We did that. Step 2, we construct a circle on the vertice of the angle, right? Step 3, construct 2 circles. Where centered on the 2 points of intersection created by the first circle and the starting angle, right? Step 4, right? If there was step 4, step 5, and basically you just want to go through until you list out every step that basically I did already for you, but I definitely want you to do it on GeoGebra, all right? That way you can get practice. Here's some old school ways that people have actually done constructions by folding paper, and it has a strong connection to origami back in the day. All right, so summary, an angle bisector is this one right here, right? We saw how we created that, and I would highly recommend that you understand the process of creating an angle bisector centered through a given point. You could practice that on GeoGebra, okay? Make sure you give yourself some GeoGebra time to construct that, all right? And if you aren't sure on how to construct that or you can't remember, just look back on how I did it, okay? Here is the angle bisector, and it cuts the angle, given angle, perfectly in half. So notice how we can very much use the compass tool to create both of these situations. All right. All right, so here's the beginning of your problems. And we can do that with assessments. All right, so everybody have a beautiful day, and thank you.